Welcome everyone to the course on audio signal processing for music applications. This is an introductory class to audio signal processing. In this lecture, we will introduce the concept of audio signal processing and then go over some common music applications of signal processing. In particular, we will mention storage, data compression, effects and transformations, synthesis, and description. These should give you a flavor of the potential of the field. We first have to define the term. So how do we define audio signal processing? And we could say in simple terms that is an engineering field that focuses on the computational methods for intentionally altering a sound. In this block diagram, we see a waveform, a sound, going through an audio signal processing system that is controlled with some device or by a person, and then it generates another signal, a modified version of the original signal. That can be a waveform or it can be any other type of signal. Since audio signals, sounds, may be electronically represented either in digital or analog formats, signal processing may occur in either domain. Analog processors operate directly on the electrical signal, while digital processors operate mathematically on the binary representation of that signal. An analog sound is usually electrical, a voltage level representing air pressure of the waveform. It's a continuous function, like the one shown on the top plot. On the other hand, a digital representation expresses the pressure waveform as binary numbers, thus as a discrete function, like the one shown in this bottom plot. The digital representation permits the use of microprocessors and computers, and although the conversion from analog to digital can be prone to loss, most modern audio systems use this approach because the techniques of digital signal processing are much more powerful and efficient than the ones based on analog techniques. Now let's start going through some common applications of the audio signal processing techniques. One such application is the storage of sounds. Thus, they are recording and reproduction. The digital representation of sound waves, such as spoken voice, environmental sounds, or music, can be recorded as electrical or mechanical inscriptions in a media and can then be recreated from these inscriptions. So the well-known CD, shown in this picture, is a media that stores a digital representation of sound as a mechanical inscription on the media. And therefore, from it, we can reproduce the sound that was recorded. Another signal processing application is data compression, or also called audio coding. The goal here is to reduce the bandwidth requirements of a digital audio stream and the storage size of audio files. There are two types